In the last video, we were introduced to irrational numbers, and we talked about how they are not repeating and they are never-ending numbers. And we looked at some pretty famous examples like pi and square root of 2 and ones like these. And so what we're going to do this time is we're going to look at how we can identify and locate these on a number line. So to get started, I want to draw a number line, and I'm just going to go from 0 up to, we'll go up to 9. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I want to think in terms of square roots when it comes to these whole numbers. So again, last time we talked about how the square root of 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. And so we'll continue to go through. 3 squared is 9, so the square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6, or 6 squared times the square root of 6 squared is 6. Square root of 49 is 7. Square root of 64 is 8, and the square root of 81 is 9. Now this is going to help us as we start to look for these numbers locations on our number line, and then we can zoom in to some of these locations once we kind of get a better idea of where they are. So let's take a look at the square root of 2. Last time what we did is we plugged it into our calculator and we had an approximate value that we found. So I want to look at this without doing that. So as I look at the square root of 2, I see that 2 in and of itself underneath here is bigger than 1, but it's smaller than 4. So that means that the square root of 2 needs to be somewhere between 1 and 2. So I'm going to draw a new number line so I can zoom in on it, and I'm going to go between 1 and 2. And I'll put this square root of 1 above here and the square root of 4 above here. And then we'll put in a half, well, 1 1/2 actually, right here. So if we were to go halfway between, this would be about 1.5, right? And so we want to look and we want to say, okay, is the square root of 2 closer to 1 or is it closer to 4? Well, it looks like it would be closer to the square root of 1 because 2 is closer to 1 than it is to 4. So it looks like it's about, maybe right in here as the square root of 2. That's an estimate, and it's an approximate, meaning it's not exactly where it is, but it's close enough, right? So we know that it's less than 1 1/2, and so the location of the square root of 2 is here. Let's take a look at another example, and let's see if we can get a good graph for it. So let's try the square root of 15. So we are looking at 15, just the number that's underneath the square root, and we're saying, okay, it's bigger than 1, it's also bigger than 4, it's bigger than 9, but it's smaller than 16. So we know that it's somewhere then in this gap right here. So let's zoom in on our number line, and we see that we are between 3 and 4. Again, I'll put up the square root of 9, square root of 16, and halfway between would be 3 and 1/2. And so as I look at this, the square root of 15 is going to be really close to the square root of 16. So I'm going to put it, it's going to be about right in there. And I don't know the exact value of the square root of 15. I could plug it into my calculator and find it, but really that's not our goal at this point. It's just to understand how we can locate these kind of in their in an approximate location on their number line. All right, let's take a look at another example. Let's try the square root of 35. All right, so we look and we say, okay, square root of 1, it's bigger than the square root of 1, it's bigger than the square root of 4, it's bigger than the square root of 9, it's bigger than the square root of 16, bigger than the square root of 25, but smaller than the square root of 36. So we're somewhere now in between this 5 and 6. The whole number is 5 and the whole number is 6. So again, I'm going to draw my number line. I'll put 5 over here, 6 over here, because we're just zooming in. We can put 5.5 in the middle too. And then here we'll say the square root of 25, the square root of 36. And again, much like the square root of 15 was, the square root of 35 is really close over here to the square root of 36. So we would see it maybe if we were to write it as a decimal as like more of a 3.8 or 3.9, or sorry, a 5.8 or a 5.9 on our number line if we were to convert it into a decimal, approximately. But for right now, this is good enough right here. We see it's pretty close to 6. So if we talk about the square root of 35, you can in your brain maybe imagine about 6 of something. All right, and lastly, what I want to talk about is what if we were to take this, if we were to take our number line that's up here, all of this right here, and look at it in terms of the negative direction of our number line. Let's go ahead and do that. So instead of going out in the positive direction, we're going to go out in the negative direction. So let's go -1, -2, -3, -4, -5, and we'll just go out to -6 this time. And we know that the square root of 1 is 1, and so then it's negative. The square root of 4 is 2, and that's negative. Notice how the negative is on the outside, by the way. If it's on the inside, then we have issues. Square root of 16, and we'll talk about that here in a second. Square root of 25 is negative. The square root of 36 is negative. All right, so now what we can do is we can then look at a negative square root. And again, the negative is on the outside. So let's talk about the negative square root of 13. When we look, we say, okay, 13 is bigger than 1, it's bigger than 4, it's bigger than 9, but it's smaller than 16. And so we get it in this gap then of this, let's draw our number line out again, of -4 and -3, and then we have -3.5, because when we're going in the negative direction we have to think backwards. Okay, we can put this over the top. We have the square root of 9, and it's negative, and we have the square root of 16, and that's negative. So again, we say, is it closer to 16 or is it closer to 9? Well, it looks like it's just past half between these, because it's 3 away from 16 and 4 away from 9. So it's going to be somewhere right in there. Again, it's an approximation. And so we have the negative square root of 13 is there. Quick note before we end. Let's say we have the square root of -16. It's impossible for us to find the square root of a negative number where the negative is on the inside, because if we were to take -4 times -4, because the square root of 16 is 4, right? So if we were to take -4 times -4, we're still coming out with a positive 16. If we were to take a 4 times a 4, okay, we're getting a positive 16. So it's impossible to get a negative number when we multiply the same number by itself. And you say, well, why don't we just do -4 times a positive 4? Well, then that's no longer the same number multiplied by itself. So that's impossible to do. So when we start talking about the square root of a -16, that's different. It does not equal the square root of the negative square root of 16. Thank you for watching. Go ahead and take a look at the next video that I have posted, and I'll see you in class.